Here we are with page 2 of your practice final. Question 11 shows us two charges where these vector arrows are representing the electric field. Remember, electric field lines will always be drawn relative to an imaginary positive test charge. So both objects A and B have these electric field vectors drawn toward them. That must mean they are both negative, because if a positive charge were placed anywhere in space around these A and B charges, all arrows point toward them. All positive charges would be attracted to negative charges. So that would be choice 3. Number 12, we have 20 newtons being exerted east on a 10 kilogram box. This force moves the box 5 meters to the east. The total work done on the box by the 20 Newton force is, well, this is just our work equation. Force multiplied by parallel displacement. And we are told that 20 newtons east moves the box 5 meters east. That's the same direction. F times D is all we have to do, 20 times 5. That would be 200. 20 times 5, that would be 100, choice 2, 100 joules. 10 kilogram box is irrelevant. We don't need the kilograms or the mass to solve this problem. Question 13, a box at rest on a horizontal frictionless surface is accelerating by a force of 5 newtons. 15 joules of work is done. The kinetic energy of the block will increase by. This is another question where there's extra information necessary to solving the problem. There's not even any equations necessary for this. 15 joules of work means that 15 joules of energy was input to the system. The box, or the block rather, was initially at rest on a frictionless surface, so all the energy put into it will go into its motion. 15 joules of work means 15 joules of motion energy is now in the box. Your answer is 15 joules. 14. Objects A and B are held 1 meter above the ground. The mass of B is twice A. The potential energy of A relative to the ground compared to the potential energy of B relative to the ground. Well, let's see. The way the question is worded, if B is twice the mass, it's twice the potential energy. The equation, of course, is M times G times H. All things being the same other than M, double M means double potential energy. So PE of A would be half the potential energy of B. So I suppose that would be choice 3. Oh, I'm sorry. No. Then the gravitational potential energy of B relative to the ground compared to A would be double. So choice 2. Sorry, I'm having trouble understanding which object we're addressing here. Object B is twice the potential of A. So choice 2 says that. Number 15, the kinetic energy of 55 kilogram skier traveling at 9 meters per second. That's a 1/2 mv squared. You plug in 55 for your m, 9 for your v, and you'll wind up with, well, it's choice 3, but that's just a calculator question. Number 16, we have a light wave traveling through a medium. The main factor that determines the speed of this wave is, well, this is addressing the index of refraction, changing the velocity of a wave. You see this 5.09 times 10 to the 14? That's your clue to use the index of refraction table, or at least that the index of refraction is somehow involved here. Don't worry about this key. I mean, it's on this video, but this is for your second practice exam. This is also on Classroom. So don't think that you can say, oh my gosh, he just showed a key for something. It's just your practice exam. So if we're changing the speed of light in a material, that would be the nature of the medium. The properties of the medium give it its index of refraction. Number 17, we have work being done in a certain amount of time to lift a mass of 12 kilograms to the top of a ramp. And the question is for power. Power is the measurement of work done over time. So we have the work of 480 joules divided by 5 seconds of time. That gives us 96 watts of power. Number 18. Another number of watt elevator can lift a total weight, that's a total force, of 2.1 times 10 to the fourth newtons with a maximum constant speed of. This is simply your power equals force times velocity version of your power equation. So we're plugging in numbers. 5.8 times 10 to the fourth, 2.1 times 10 to the fourth, substituting the power and the newtons, solve for velocity, that means you would divide, and your answer would be, let's see, it's choice 3, so 2.8 meters per second. Number 19, a police officer directs a radio wave at a vehicle moving toward the officer. So this is a Doppler effect question. If the object is moving toward the source of the wave, then the moving object is receiving the waves more frequently than he otherwise would if he was not moving towards it. So choice 4 is the answer to describe this situation. Number 20, a light wave strikes the moon and reflects toward the Earth. As the light wave travels from the moon towards the Earth, the wave carries. This is energy only. All waves are only a transfer of energy. Energy is what propagates. Mechanical waves require a physical medium to propagate the energy, but matter is not permanently disturbed. Even electromagnetic waves that this question is addressing don't even disturb matter, nor do they transport it because no waves do. Choice 1 would be the choice for all waves, no matter what. And number 21, the time required to produce one cycle of a wave. This is a definition question. A period measures time. So that is our answer. I'll close this video and I'll start another one for the next page.